Hello. Hi. Today I uploaded a video which is called Void Distributed KV Database, something like that. So I wanted to give out an in-depth explanation of what it is about and what's my thought process behind writing the code. How did I structure the code and what can be improved, and just a conversation and the concept behind implementation. So first, let me. Okay, so this is the whole architecture diagram which I implemented. So first, if you haven't seen the video, I'd link that in the description. You can just watch it, but it doesn't have any audio or something. I added few subtitles in it, but most probably it is very difficult to understand what is going there. So that's why I'm creating this video, so that it can be a clear understanding on the implementation aspect of this whole void DB and why I'm trying to implement this and how I'm going about implementing this whole system. Okay, so this is the architectural diagram of this project. Most probably what I did is I have one, two, three shards of NoSQL databases. So my initial plan was to write the whole NoSQL database by myself, like an at least a simple JSON database or something, and implement all these distributed system concepts on one on top of it. But and then I decided to use an already existing open project. The original version of this bold DB is closed, but there's a bbold DB which is written on top of Go, and then so I'm using this bbold DB for this project, and this whole distributed and this whole architecture is written on top of this bbold DB, which is an yet another key value per DB. So I could have written a simple JSON database data storage and then could have implemented all of these, but I just wanted to straight jump into the implementation. That's why I just used this bbold DB, which is written on Golang. So the stack for this is Golang and maybe and Makefile. So the tech stack is completely Golang, and so okay. As a part of implementation, I have created three NoSQL sharding and three read replica for this individual NoSQL sharding. And I have three handler. First one is a get handler, a set handler, and then reshard handler, and a couple of implementation handlers. But these three are the important handlers. The get handler is used to get a key, and set handler, obviously as the name suggests, used to set a value into the handler. Sorry, set the value into the database, and then the reshard handler reshards the whole system. Suppose you have let me explain what is sharding, what is resharding in the upcoming slide, but and that as of now I think it has an black box where something called a resharding happens if I call this handler, and then there is there are multiple go routines which keeps running, and there is a queue for replica creation. Yeah, even though the replica DB has been already created, there is a queue which takes data from the NoSQL databases and then put it into our replica, and then this is aided through multiple go routines which runs at regular intervals. That's the whole implementation idea behind this project. Okay, the first key implementation which I tried is static sharding. So first, what is sharding? Suppose consider a huge database. All the examples which I give, consider it as n million records or 100 million records or something like that. Huge amount of data. Consider there is a huge amount of data that you keep writing in your database. Doesn't matter if it is a relational or non-relational database. Over a point of time, you have no other option to shard it down. Shard is technically splitting it into smaller units. As a norm of distributed system, we call a system as a distributed system when it has its individual clock. There is no global synchronization across all the clocks of the system, and when one goes, the whole system needs to be working. Technically, it should be fault tolerant, and as much as possible we try as close to implementing the ACID principles in databases. When there is only one database, it is obvious the data is atomic, consistent, and everything durable, blah blah blah. But when you shard the system into multiple pieces, there are very many new problems which occurs, and we need to start solving for this newer problem of sharding. So the first stage of my implementation is there are different addresses, like example localhost 8080, 8081, 8082, and so on. Some random addresses. Each addresses will point to a shard. So suppose there is 10 million records. The records are now sharded into these three smaller databases. So sharding comes with its own problems, like how do we maintain consistency across the shards? What will happen if this whole database goes down? How do you handle then lot of other problems which comes with splitting the database. So my first implementation is I am sharding this database into multiple smaller databases, and how I'm storing the data into these databases. What are the criteria by which I am identifying that record A should go into this one, record B should go into the other one, and so on. I will discuss in the future slides. This records, suppose now in my implementation there is 3 shards which is identified by which denotes by 3 addresses. So if I enter localhost something, it goes to shard A, local 81 it goes here, 8082 it goes here, and so on. But how do we suppose when I am calling my set handler and I am giving a key and a value, which shard do I put this value? This is determined by multiple ways. We can do this any way as we like. Let me give few examples how do you do it. So first take this let's say example, suppose the key is void. What we can do is we can use some random ways to just allocate the data into the database. Suppose if it is from A to G, go into this shard, H to something like U or something, or W something, or you just 26 by 3 and the mod you just add it up in the last dB, and then you can just put the values there. That's one way of doing it, which this is not the there is no right way or the wrong way. Each way has its own set of problems, and it's just dividing it into multiple shards. So here, since we are doing a static shard, we know that there is just 3 shards here. Sometimes, most of the times the shards are dynamic, so that means you dynamically add in databases. suppose there is, suppose you consider a trading website, and if there is any problem that occurs in this trading website, the first thing that needs to be done is isolating the users who has all these problems. So suppose there are like a million, in million users there are like 20,000 users who has this problem. We just isolate into one separate smaller instance or a smaller database, and then the other database will work on its own, and we can just solve whatever problem in this database alone. So initially we had like n databases, but because of this problem something new comes up, and then we move the data through to this database, and then we just solve the problem. So okay, coming on to this, there is what I did is I used a concept called consistent hashing. Like okay, I used a concept called consistent hashing. Suppose now we have three shards, that is three databases. What I'm doing is, this three can be in, yeah, my code is good enough to identify how many shards ever we just given. So assume that there is three shards here. Now I wanted to set this void with a value called 1. So what happens is, in consistent hashing, assume that this is a circular design, and we have different parts, that is we have three shards here, and each shard will be given a value. Like example, you can give it as 0, 1, 2, whatever you want. By some rules, you can do a mod 3, so on, and then just put it in this number. So this has an unique address of 0, 1, and 2. Suppose we have an we need to set this void into our shard database. What we need to do, what we are doing here is, we are hashing this value, and then we'll get a number out of this hash. That needs to be consistent, obviously. Use the same algorithm across. The next time when this void comes, again it will give you the same value. Suppose it gives 1, 2, 3, 4, 5. We again mod with a value. Like for example, now I'm doing modulus with 3 because there's 3 shards. You can do modulus with whatever you want. But that should remain constant. Suppose the if it comes as 0, we put it here, 1, 2 here. But usually the values are not 0, 1, 2, and it might be spread across. Like for example, 0, 100. Assume your this index of the shard is 0, 100, and like 200. Suppose your mod is like 50 or something. What you do is you go clockwise, and then you just store it in what's the next shard available. Suppose if it's 36 or 58 or something, it's here. So according to clockwise, it should be stored in this shard. And if some value is in between these two, it will be stored here. Some value between these two will be here. If that value exactly matches with the index, then we store it directly into it. So this is the concept which I am applying here for consistent hashing. If you would have seen that video, what happens is, when you try to set an value, but you suppose this is index 0, index 1 and 2, it has an address of 8080, 8081, 8082. So what I'm trying to do is, I am trying to act like a load balancer here, technically. So suppose I am trying to curl on this 8080 platform and trying to set this void here. But after hashing, the system identifies that you can't set the values in the shard which has an address of 8080, because the shard the hash value is around 1, and the one denotes that it goes to this database. So what happens is I automatically redirect it to this database, and I store the values here. And the next time when I try to get from the same happens with get. If I try to get the value from here, I calculate the hash, and I identify that it doesn't belong to this database, rather it belongs to some other database, and I automatically redirect to the database. This is technically splitting up the, suppose you have an 10 million record or something, you technically split the load between 3 shards here, and if the more shards we have, the more separated we have, the smaller the interval, the load almost splits easily, and it's approximately 1 by n. N is the number of shards. So if we keep on increasing the number of shards here, the distance gets reduced and the load gets evenly spread. It should approximately come to 0 if we have huge number of shards, which doesn't happen actually. So the concept behind is, now I have 3 shards here. The gap between the gap between shard this gap between the shard A, shard B and shard C is huge. So there can be an uneven distribution of load at times. So when I add more servers and more shards in, the gap becomes very smaller. Thus, the load slowly gets evenly distributed by this formula of 1 by n. This is the concept I am using to shard the values. Power of 2 shards. The another way of doing it is using power of 2s and sharding the value. 1. Suppose what this rule says is, suppose you have an hash h1, hash h2, hash h3, hash h4, hash h5, and you have shards in power of 2, that is 1, 2. The next time when you wanted to expand, do 2 square, like 4 and so on. If you do this, if you shard this way, what happens is, suppose you have only assume you have like 2 shards here, like this record can go to here, this record can go here, this record can go here, and so on. Assume h1 and h2 goes into the shard 1 and h3, h4, h5 goes into shard 2. So now what happens here is, because of this power of 2, suppose I expand it into 2 more shards, and every time when I expand with powers of 2s. So now it is 4 and then 8 and so on. When it reaches 1024, it gets a little tricky here, and I will come back to it later. So now what happens is, if you do a power of 2 here, that is, how do you split it here? You get an hash value h1 and you mod it with 2, and you mod every value with 2 and so on. So this will give you the resultant index, and then you put it in the appropriate shard. So when you do mod 2, assume that you increase the shard from 2 to 3. What happens is, now you will be doing mod 3 here. So doing a mod 2 and mod 3 would completely reshuffle the values of this h1, h2, h3, h4, h5. it might be the same. There can be a value reshuffling and so on. So what this power of 2 says is, if you do a mod of power of 2, that is, now you have 4 servers, 4 shards, and you do a mod 4, what happens is it splits between the existing groups all the time. That is, suppose there is an H1, H2, H3, H4 and H5. In case 1, these both goes to a one shard, the other 3 goes to another shard. Now, that is, we have 2 shards here. These 2 goes to shard A. To all these 3 goes to shard B. Assume that it goes like this. How do you do it? You do mod 2 and then you put it in the appropriate shards. Now, when you this is 2 power 1. When you do 2 power 2, that is 4 shards, you have now C and D as well. So what this sharding based on this power of 2 does is, now instead of 2 you mod by 4 here. Thus this H1 and H2 regroups into 2 group or becomes 1 group, that depends on the hash, and H3, H4, H5 regroups into n 1 group or 2 group or 3 group, that depends. But what happens is there won't be a mix of values. These 3 will split into certain groups, and these 2 will go and split into certain groups. Suppose you have A, B, C, D here. Now, earlier it was in A, now this is in A and C, but the values in this group won't mix. That is, it won't go to C or A, rather it will go to B or D, whatever. This is the by doing this, there is no mixing of values while sharding, and this is one important technique of resharding using power of 2. When you wanted to expand the number of shards, and you can use this technique. But when it is in 1024, 2 power 10. So what happens is, the next stage is adding another 1024 servers, which is not feasible. That's one drawback of this method. Yeah, what I talked about now is technically resharding. Yes, the final implementation I did here is called read-write replica. Now if I go back to the diagram, you could see that there is 3 NoSQL databases, and there is corresponding 3 read replicas as well. I didn't implement write replica, but it is straightforward to implement write replica as well, because let me first explain what a read replica is, and then why are we doing replica and so on. What are the problems? Everything in distributed system comes with its own bunch of problems, and we'll try to address few of it. And I tried addressing few of it in this project, but there are a lot more to address. So first, let's see what a replica. There's a difference between a replica and backup. So first, both looks very similar. That is, you take a copy of something, but you do a replica when because there can be an system fault occurring, and at that time you would use this replica. And backup is something which is used when there is a human error. Suppose you could see a famous meme that an intern comes and writes delete star record on his SQLite table. What's gonna happen? For all those cases, there will be an regular backup on every regular interval, like 5 seconds or 10 seconds, 1 second, less than that. At that time, you can be restored using backup, and this replica is for the fault which happens in our system. Suppose, like in this diagram, you could see I am trying using this get header. I am trying to go hit this NoSQL database server and trying to get some value and trying to get void. Suppose if this server is down, I could get the same value through this read replica as well. You can design it however you want. Suppose the load which comes to this SQL database is more than a million or 100 million or something. A heavy load on this, if there is a heavy load on this SQLite database, you could completely prevent, that is both write and read is happening. Assume both write and read is happening and there is a heavy load on this SQLite database. You could completely isolate that. There shouldn't be any read from this SQLite, and all you can do is write, and every reading should happen from this replica. And that is one way of reducing the load here. Everything is a possibility here, and it's all implementation nuances and its own set of problems, and how do we address it. What happens is, we have a database here. We are replicating the database. That is, we're technically taking a copy of the same database with the same bunch of data, and now you can read it here as well as read it here. I have enabled reading in both the places. You can just switch it off wherever you want. And then what happens is, when you try writing into this read replica, I am not allowing that, because this is read replica. You can only read data from it. Why? Because assume there is some mechanism, that is this go routine takes all the writes here and again writes back to this read replica. That is, we users can't write into this read replica, but the system somehow writes it into this read replica, and you add some other data in the read replica which is not there in this write database. There is an issue with consistency here. That's the reason why I am preventing people to write from my write replica. So now we have 3 NoSQL databases, its corresponding write replica, and every 1 second, or what I'm doing is, I'm doing every 0.5 seconds, I would just see if there is any data in this queue. So I write the data here as well as put it in the queue, write queue. It's technically I put the value in the write queue, and then I write it in the SQL database, NoSQL database, and then I would delete, take a value, write it into its corresponding read replica, and then delete the value from here. If this doesn't happen, it tries again after sleeping, after trying for a minute or 2, and then it sleeps for a second or 10 seconds, and then again tries and so on. So this is how I have implemented the read replicas here. And now what happens is, you can go and read directly from this read replica, as well as you can go write the values in this. Suppose we call it as zone A, zone B, zone C. We write in the shard of zone A, and then we can read it from the shard of zone replica of zone A. Now the load has been tremendously split. Suppose you have an application that has a million writes and a very few million reads and a very few writes. Writes are always costlier than reads, because the implementation below, even though you write it in a go routine or a thread or something, the implementation in the lowest level is single threaded, so it is always comparatively slow when compared to read. And that's the reason why for a system like this that has a lesser number of reads and more number of writes, it is good to just isolate both of them. And now this comes with a bunch of problems. Now I have just implemented one replica here. Assume there is 2 replicas and one NoSQLite DB. We have 2 replicas and one NoSQLite DB for the same zone. So now I call the set with void and some value, and first it puts in the queue. Now, in networking, anything can happen. You can't assure that, because it's all in its individual server. This is in 8080, 8081, 8082, 3, 4, 5, something like that. It's all in its individual server. So packet needs to travel from one place to another, and anything can happen at this time. So suppose you reach this zone A. How? Through my consistent hashing, your own consistent hashing algorithm, you reach the zone A. That's what I did. Reach the zone A, and then you store the value here, and then you reach the replica A, and then you store the value. Assume that when you are trying to write the value into replica B, there is some failure here. But now this one has the value, this has one value, this has some other old value. Suppose void has been updated into something, it has an old value of void, these two has newer value of void. Now when you try to read what will happen is, you have two voids here with the same key, but the value is different. So how do we handle this case? Which is the right one to pick? So to handle this, what I'm doing is I am adding an additional timestamp to the existing key value pair. Suppose you write the value here, I add along with the key value, I add a timestamp as well. So here it has key value timestamp, irrespective of a failure here. And my go written again tries anyways to write it back into the shard. So that part is being taken care. The major problem I have for me is when I try to call a get when I do a get request, now I'm getting two values for the same keys, and I wanted to identify which is the right one. So the best way to identify is I've added a timestamp along with the key and value, and I will always pick up the latest timestamp, so that might be the most accurate value. So like how I implemented the read replica, you can implement an write replica as well, which allows only to write, and doesn't allow you to read, and works the same way. This is my whole implementation of void distributed key value pair DB, and there are a lot of scopes of improvement like global clock, how is the concurrency, and I have benchmarked the result as well, and then I will just add the benchmark result at the end. And hope you like this video. See you in some other video. Bye.